Hello, welcome to another Olympiad math video. So in this video, we are going to be solving 10 Olympiad math problems. So before we get started, please like and subscribe so I can keep making more content and keep pushing out videos. So the first thing we're going to do is we're going to subtract 2 from the right side so that the equation is equal to 0. Now that we have done that, we are going to rearrange our x to the power of 6 so that it is x cubed, and then it'd be x cubed to the power of 2 minus everything else stays the same. Now we are doing that so that we can have our x cubed be changed to a letter variable, for example. So we're going to let x cubed be equal to y. It's a lot easier to solve for just y than it is x cubed. And then once we get to that point, we can exchange x cubed for y. So we'll have y squared minus y minus 2 is equal to 0. Now we can factor this out, and at this point you should have a good understanding of factoring equation. And this one factors out nicely into y minus 2 times y plus 1 is equal to 0. And now we're just going to set both sides equal to 0. So we'll have a y minus 2 is equal to 0, and a y plus 1 is equal to 0. So we'll add 2 on the left equation. We'll have y equals 2, and exchange our x cubed is equal to 2, which means that if we were to cube root both sides, our x would equal the cube root of 2, or you could say 2 to the power of 1 over 3. So let's do the other side. So we'll subtract 1, we'll have y is equal to negative 1, exchange y for our x cubed, and now negative 1 cubed is actually just negative 1, so therefore x would be equal to negative 1. So our two answers are negative 1 or 2 to the power of 1 over 3. So let's go ahead and work on another one. We have 4 to the power of x plus 1 is equal to 32. We are going to rewrite 4 and 2 as 2 to an exponent. So 4 would change to 2 squared, and 32 would change to 2 to the power of 5. Now, what we can do with the 2 squared to the power of x plus 1, we can apply some exponent properties. So we can multiply those guys out. So we'd have 2 to the power of 2x plus 2 is equal to 2 to the power of 5. Now, if we had a to the power of b is equal to a to the power of c, then we could say b is equal to c. So in this situation, 2x plus 2 would be equal to 5. So we would subtract 2. We'd have 2x is equal to 5, or 3, sorry. 2x is equal to 3, and then we would divide 2. So we'd have x is equal to 3 over 2. Overall, that one was pretty simple. So let's go ahead and work on the next one. We have a fun one here. We are solving for a plus b is equal to abc. And we got b plus c and c plus a. All those are equal to abc. So we're going to number these. We're going to say we got 1, 2, and 3. Now we're going to solve for 1 minus 2. So if we did 1 minus 2, we would have a plus b minus b plus c is equal to abc minus abc. So that would leave us with an a minus c is equal to 0, which means that a is equal to c. So let's do 2 minus 3. So that's going to be a very similar situation where we're going to be left with a b minus a is equal to 0, which means that b is equal to a. So if we know that a is equal to b and a is also equal to c, that means b is equal to c as well. So that means A, B, and C are all equal. Now, let's go back to number 1, our original equation, to solve for A, B, and C. So we have A plus B is equal to ABC. We can exchange the B and the C for A's. So we would have A plus A is equal to A times A times A. Now that would be 2A is equal to A cubed. Or we could subtract 2A and we'd be left with A cubed minus 2A is equal to 0. Now we can factor out an A, so we have A squared minus, or A times A squared minus 2 is equal to 0. Now if we were to square the inside of this equation, so if we squared the A squared minus 2, we would be left with an A times an A plus or minus the square root of 2, again is equal to 0. That makes it easier to solve for 0. So now to solve for 0, we just set both sides equal to 0, and we'll have an A is equal to 0 and is also equal to plus or minus the square root of 2. So that wraps up that one. Let's go ahead to another one. Alright, so we're going to rewrite our our 16 and 8 as 2 to an exponent. So right now we have 16 is equal to 2 to the power of 4, and 8 is equal to 2 cubed. Now when we have an exponent to an exponent, we can just multiply those exponents. So we would have 2 to the power of 4x minus 2 to the power of 3x is equal to 0. Now with the 2 to the power of 4x, we're going to change that 4x into a 3x plus x. Now, the reason we're doing that is when we have an exponent, so a to the power of m plus n, that is the same thing as a to the power of m times a to the power of n. So therefore we would have 2 to the power of 3x times 2 to the power of x minus 2 to the power of 3x is equal to 0. Now we can factor out a 2 to the power of 3x. So 2 to the power of 3x times 2 to the power of x minus 1 is equal to 0. Now we just need to set both sides equal to 0 in order to solve for it. So 2 to the power of 3x cannot equal 0. And that is because if no value you could put in for x would make 2 to an exponent equal to 0. So therefore it's not possible. That means 2 to the power of x minus 1 equals 0 has to be our solution. So if we added 1 to both sides, we'd be left with 2 to the power of x is equal to 1. And then an important property to remember is if we had a to the power of b is equal to a to the power of c, b would be equal to c in most cases. So because we know that, if we can change 1 to the power 1, or change 1 to 2 to the power of 0, which is also equal to 1, we would have our a values would be equal, 2. And if 2 to the power of x is equal to 2 to the power of 0, that means x is equal to 0. So x is 0 on this one. So let's move to another one. So in this one, we got 9 to the power of x is equal to 27. First thing we're going to do with this one is we are going to rewrite 9 and 27 as 3 to a power. So we got 3 squared to the power of x is equal to 3 cubed. So exponent properties, again, we have a to the power of m to the power of n was equal to a to the power of m times n. So we would have 3 to the power of 2x is equal to 3 cubed. Now another exponent property, again, a to the power of b is equal to a to the power of c, which means that we can set b equal to c. So we would have 2x is equal to 3. Divide 2 on both sides. we're left with an x equals 3 over 2. So with this one, let's go ahead and check our answer, because it's a little, I'll show you an easier way to do it. So if we would have 9 to the power of 3 over 2 is equal to 27. Now right away that might seem kind of annoying to solve, but we can change our 9 into a 3 squared. So we have 9, or 3 squared to the power of 3 over 2 is equal to 27. As we have learned, you would multiply 2 and 3 over 2. So we would have a 3 to the power of 6 over 2, or 3 cubed, which is 27. So that's an easier way to solve that without trying to calculate in your head what an exponent 3 over 2 is. So let's do another one. Alright, we got x to the power of x to the power of 4 is equal to 64. So we are going to rewrite this. Now, the reason we are putting both sides to the power of 4, the best way is to show you, I guess. So we're putting both sides to the power of 4 so that we can apply some exponent properties. So if we had a to the power of m to the power of n, it'd be equal to a to the power of m times n, like we talked about. But we can also just switch those values so that instead we'd have a to the power of n to the power of m. So what that'll look like is we'll have a to the power of x to the 4th times 4, like we talked about, and then we can switch those values and put the x to the power of 4th on the outside. So this is where we're sitting. We have x to the power of 4 to x to the power of 4 is equal to 64 to the power of 4. Now, we can rewrite 64 as 8 squared, which is still to the power of 4. And with our exponent properties, we'll have x is equal, we'll have 8 to the power of 2 times 4, which is equal to 8 to the power of 8. Which means that we'll have x to the power of 4 to the power of x to the power of 4 is equal to 8 to the power of 8. That is a lot to say. But the reason we have done that is we can now just say x to the power of 4 is equal to 8. Because when our a values, or our base, and our exponent are the same on both sides, we can just set the base equal to each other. So we'd have x to the power of 4 is equal to 8. Therefore, x is equal to plus or minus the 4th root of 8, or 8 to the power of 1 over 4. Alright, let's do another one. So we are solving for x and y in this situation, and we want to know what x plus y is equal to. So we have x plus xy plus y is equal to 54. The thing to remember here is that x and y are both positive integers. When we're solving this, we need to keep that in mind. So we are going to factor out an x. So we'll have an x times 1 plus y is equal to 54. Now, in order to solve this, we need to make this factorable. So how we're going to do that is we're going to add 1 to both sides of this equation. So I have an x times 1 plus y plus 1 is equal to 55. Now that we have done that, we can factor this equation. So we'd have an x plus 1 times a y plus 1 is equal to 55. Now, we need to solve for x plus 1 and y plus 1. And how we're going to do that is we're going to factor 55. So 55 can either be 5 times 11 or 11 times 5. Now you might be saying it might be 1 times 55, but if you remember, and this needs to be a positive integer, which means that it's greater than 0. And if you plugged any number in for x greater than 0, it'd be greater than 1, right? So if we plugged in even a 0 for x, which isn't a positive integer, if we plugged in 1 for x, 1 plus 1 is 2, therefore it can't be 1. So now we need to have x plus 1 times y plus 1. And how we're going to solve this is we're going to have our 5 times 11, 11 times 5. So we're going to set both sides of this equal to 5 and equal to 11. It's similar to having to solve for 0. So in the first situation, if our x plus 1 is equal to 5 and our y plus 1 is equal to 11, x would be equal to 4 and y would be equal to 10. So in the other situation, we'd have x plus 1 is equal to 11 and 5, and then y plus 1 is equal to 5. So x would be 10 and y would be 4. So in both situations, we would have a 4 plus 10 or 10 plus 4 to solve for x plus y, which means that x plus y is equal to 14. That would solve. All right, so we have a square root of x plus square root of negative x is equal to 2. So first things first, we're going to subtract the square root of negative x. We're left with a 2 minus square root of negative x. And then we're going to square both sides to try and get rid of these squares. So that'll leave us with an x is equal to a 4 minus 4 square root of negative x is minus x. Now we're going to subtract 4 and add x from the right side. We'll move that over to the left. So we'll have a 2x minus 4 is equal to negative 4 times the square root of negative x. Now we can divide both sides by 2, like so, and then we'll be left with an x minus 2 is equal to a negative 2 times square root of negative x. Now we're going to square both sides to, again, get rid of these exponents. So that'll leave us with an x squared minus 4x plus 4 is equal to a negative 4x. Now we can add x from the left side to the right, so I have x squared plus 4 is equal to 0. We'd subtract 4, so we'd have x squared is equal to a negative 4. Now we would square both sides again. We'd have an x squared is equal to plus or minus the square root of negative 4. Now something to remember is that that I is equal to square root of negative 1, which means that we can replace the negative value in our negative 4 to an I, and then the square root of 4 is 2. So our final answer would be x is equal to plus or minus 2i. Let's move on to another one. So we got 4 to the power of a minus 36 to the power of b is equal to 28. We're going to rewrite 4 and 36 as 2 squared and 6 squared. Now, using exponent properties that we've talked about previously, but I'll write it at the top again, we can switch our 2 and our a and our 2 and our b. So we would have 2 to the power of a squared minus 6 to the power of b squared is equal to 28. Now, what we're going to do is we're going to apply a fun equation. So if we had x squared minus y squared, that'd be equal to x plus y times x minus y. In this equation, our x value would be 2 to the power of a, and our y value would be 6 to the power of b. So that means we would have 2 to the power of a plus 6 to the power of b times 2 to the power of a minus 6 to the power of b is equal to 28. Now, how we would solve for this is we need to factor 28 and set either side of this equation equal to those values. So some options are we could have 1 times 28, or we have two other options. We'd have 2 times 14 and 4 times 7. Now, you might want to say that you could flip those and say 28 times 1, 14 times 2, and 7 times 4. But the reason we can't is because the left side of this multiplication is always going to be greater than the right side. So 2 to the power of a plus 6 to the power of b will always be greater than 2 to the power of a minus 6 to the power of b. And that is simply because it is addition instead of subtraction. So that being said, this can only be solved one way. We can't use 1 times 28 and 28 times 1. Now looking at this, so looking at 1 times 28, for example, there's no a and b value that would be equal to 1, because no exponential value would give us that answer. So therefore, it cannot be 1 times 28. Because another thing to remember is that the values are going to be even, and that's the more important part. 1 is an odd number. No a or b value is going to give you an odd number in this equation. So therefore, the first and the last option, because there's an odd number with 7, will not work, which means 2 times 14 is our only option. So therefore, we need to set our 2 to the power of a plus our 6 to the power of b equal to 14, and then our 2 to the power of a minus 6 to the power of b would be equal to 2. I flip-flopped those when I wrote those. So now we just need to solve for a and b. So something we can do is to plug in a value for a. So we're going to say a is equal to 3. If we did that, and we solve for that, b would then be equal to 1, because 2 to the power of 3 is equal to 8, and 8 minus 6 to the power of 1 is just 6. So 8 minus 6 is equal to 2. And our second equation, 8 plus 6 is equal to 14, which works out perfectly. Problem, finally. I'm getting tired of talking. So we have 25 to the power of x minus 15 to the power of x is equal to 9 to the power of x. So we're going to divide by 9 to the power of x on both sides to cancel out 9 to the power of x. Which means that we'll have 25 to the power of x over 9 to the power of x minus 15 to the power of x. And with those fractions, we can pull out the powers since they are equal to each other. So we'd have 25 over 9 to the power of x minus 15 over 9 to the power of x. Now what we're going to do is we're going to simplify these fractions a little bit. So we can change 25 to the power of 9 into 5 over 3 squared, and then 15 over 9 is equal to 5 over 3. Now using exponent properties that we talked about before, we can switch our 2 and our x so that it looks like that, which is perfect because now we can change our 5 over to the power of 3, or 5 over 3 to the power of x. We can set that so that is equal to y. So therefore we would have y squared minus y minus 1 is equal to 0. Something to remember, that y has to be greater than 0, because 5 over 3, if you put that to the power of anything, plug in anything into x, it will not equal 0. So how we would solve for y now is we would use the quadratic equation. Now I've worked through that in some of my other videos, so we're not going to do it now. But if you plugged this equation or use the quadratic equation to solve for it, you would get y is equal to 1 plus square root of 5 over 2. Now, since we know that that is what y is equal to, we also know that y is equal to 5 over 3 to the power of x. We can set those equal to each other. Now that we have done that, in order to solve for x, solve for the exponent, we are going to set both sides to the natural log function. So let's get on a new sheet. So we have natural log of 5 over 3 to the power of x is equal to a natural log of 1 plus square root of 5 over 2. Now we're going to use some natural log properties here. If we had log of m over n, it would be equal to log of m minus log of n. Then if we had log of a to the power of x, you could move that exponent to the front, so we'd have x log a. So if we did that with our equation, we would have x times the natural log of 5 minus natural log of 3 is equal to natural log of 1 plus square root of 5 minus natural log of 2. Now in order to solve for x, we just need to divide the natural log of 5 minus natural log of 3. And we would be left with natural log of 1 plus square root of 5 minus natural log of 2 over natural log of 5 minus natural log of 3. And that ends our 10th and final Olympiad math problem. So thank you for watching. If you liked this video, please like it. If not, comment down below, or maybe don't. And yeah, please subscribe. Stay tuned for more videos.